Hello, everyone. Welcome to the Computer Science Department Colloquium. For folks who don't know me, I'm Jung Lee, and I'm the chair of the Colloquium this year. It's really my great pleasure to introduce our today's Colloquium speaker, Professor Wu-chang from Portland State University. Last Saturday, both Wu-chang and I were invited to speak at a cyber camp for high school students organized by Professor Rakesh Boba from Oregon State. And I had known Wu-chang for a long time, so I invited him on the spot to give a colloquium talk, and he very happily accepted my invitation and was really available right away. So, so here we have Wu-chang. Wu-chang currently works on topics in cloud computing and security. And he has been particularly doing projects including developing capture flags and code labs to teach advanced topics in security. And I know he has also done a lot of outreaching to high school students using all kinds of vehicles, including some funded by NSF and the NSA. Right? So Wu-chang has a lot of experience these days in reaching out to students at all levels and engage them in doing cybersecurity, thinking about cybersecurity. And it's all very cool stuff, as I know. So it's really great to have Wu-chang. So without further ado, let's welcome Wu-chang to give us the curriculum talk for today.
All right, thanks, June. So as June mentioned, I really like playing games. I believe learning should be fun, and I believe giving students an experience that's fun is an extremely valuable thing for me. That's what I look for. And so speaking of high school students, this might not look like a high school project, but actually this was built when Nicholas was a high school student. He's now a sophomore in college. This is a CTF that we built on Google Cloud. It's called Thunder CTF, Learning Cloud Security on a Dime. You can play this CTF with this link, and I think it was shared out. So hopefully if you want to play along, we'll be playing one of the levels on this game, and then you can see exactly the kind of I guess experience a student would have when they're playing this game. Okay, so let's begin. I think everyone has seen over the last decade, there's been a race to the cloud. There's a survey done recently that looked at what businesses were going to do in terms of deploying their infrastructure to the cloud. And you see a lot of people are shrinking their on-premise footprint, and they're basically shifting it over to the public cloud. Some people are trying to do private cloud deployment. So something like the government, for example, would want their own machines and then just run the cloud software in their hosted environment. Some people want to do hybrid cloud where they have some infrastructure on premise because of maybe regulations, but then they can leverage some of the economies of scale of a public cloud. So there's a lot of hybrid cloud action going on. There's multi-cloud action going on where you don't want to be beholden to one vendor, so you're going to try and deploy on everything. But there's a lot of action in the cloud. But there was another survey. In fact, this is the same survey. They asked this question: what are the biggest challenges for organizations moving all their stuff to the cloud? And some of the usual suspects are there. You don't want outages. It turns out you have very reduced visibility in the cloud. It's not like you can just go and tap into your machine, log in, and maybe measure the network traffic going in and out of your closet, these sorts of things. There's cost. So it's ironic because the cloud was supposed to save you money, but if you don't do it right, it's going to cost you way more money than it would have. There's vendor lock-in, right? Like you're basically unable to move your application if you have tied it too deeply to a particular vendor. And then there's some privacy issues because now your data isn't on site anymore. And so you could have regulatory issues where you're not allowed to actually have customer data off site. And that's a potential concern. But if you look at the top of the list, this is what you'll see. You'll see security is #1. That is the biggest trepidation. And then coming in third is people lack experience. They don't know how to navigate the cloud. They don't know how to set the thing up properly. And when you combine 1 and 3, you got some problems in deploying applications to the cloud. This is from Forbes. I don't have a, oh yeah. So this image, I can share a link to the slides later, but this is a clickable image that will take you to the article I pulled these images from. Okay, so why do we have such trepidation when it comes to securing the cloud? Well, if you look at what we're doing, we're taking one really complicated problem that we're already having a hard time with. So this is, just regular legacy security. So operating system security, routers and firewalls, user management and authentication. We have access control management. We have an inventory problem where we don't even know what we're running on premise. And then we have to patch and update all of that infrastructure. And this is what we have now before the cloud. This is like what we're running, like we're, in a university. If you talk to your IT department, they're like, they gotta take care of all of that. And we already can't do that well. But what we're asking is, okay, you have to take care of that. And you have to take care of an entirely new set of problems in the cloud related to security. You have a different way of doing access control. You have this IAM access control. You have a different way of configuring the policy for it. You have new things like account access keys and tokens and being able to manage who gets what and what access do they do those things have. You have issues with credential rotation. So, when I issue these things, I got to be able to rotate them out in case one of them gets compromised. I have to configure all of the different native services that I'm leveraging in the cloud. So often cloud providers give you all kinds of cool features and services. Well, now you have to configure each one of those so that it's securely accessed within the project itself. We have new ways of doing authentication. We have federated identity providers. We have new ways of managing, we call this continuous authentication with zero trust networks. We have different abstractions of computing. We have containers, we have serverless computing, we have API security issues. So we have all of that, right? On top of the problem that we were already having a hard time teaching students and getting people capable of. And so this really is leading to all sorts of problems. And so this is not a surprise. We have issues with misconfigured storage buckets. So it's election season. So here are examples of, voter data just being left open in the cloud and accessible by everybody. The US military had this social media collection thing that they left on a storage bucket, and that got exposed. We have things like misconfigured snapshots. So I'm trying to back up and snapshot some of the operating settings of my platform, maybe a virtual machine image snapshot. And so if that's not secured properly, then you can leak all of your customers' data based on a backup. You have misconfigured databases. So here are some examples where, a Google Cloud database was left wide open. Here's another one where I think this might be an Elasticsearch database. I forget which one, that basically exposed a bunch of banking information and mortgage documents in the cloud. We have cases where insiders are given way too many privileges than they should have, and then an adversary slips in a malicious insider into an organization, and then they do the exfiltration of all the goods. And so this is a Twitter case where two insiders were basically turned by the Saudi government to basically exfiltrate data of Saudi citizens on that platform. And so if they, these two particular engineers were given elevated access to actual user data when they probably shouldn't have. We have issues with exposed login credentials. So again, this was from Uber. They left some things on a bucket, and then those credentials got exfiltrated. We have exposed API, account, and OAuth and SSH keys. So one of the ways we authenticate in the cloud is to do access keys. And we're passing this around like candy and hoping that nobody compromises any of the things that are being passed around. But of course, this is really difficult. So Starbucks basically pushed out one of their essential API keys onto GitHub. Imperva is a company that had a data breach because they also had an API key that was exposed that the adversary could download and use. And so there was a study, I think this is from NDSS last year. They built a system where they were just scanning all the Git commits. And then they were basically trying to pull out things that looked like access keys. And so you can see on the bottom right, you can see the kinds of things they were looking for. So SSH keys, API keys, or these are account access keys, API keys. And they basically saw that about 1,700, almost 1,800 keys per day were being pushed up into repositories, and it took them 20 seconds because you can basically subscribe to the event feed of GitHub, and it just took them 20 seconds before discovering a key. And so, these were good guys doing this. You can guarantee yourself that there is some adversary doing this same thing and basically finding all of these accidentally exposed keys and then going and using them. We have exposed metadata. So this happened last summer. It got Capital One in big trouble. In fact, Ron Wyden was really mad at AWS because he blamed AWS for this problem. There's this metadata service, and we'll get back to this metadata service when we talk about one of the levels in this CTF. But it was a really easy way of turning one vulnerability into a jailbreak of the entire platform. And so this was a case where there's this thing in security. It's called a WAF. It's like a web application firewall. It's basically a reverse proxy that takes all the web requests, terminates the connections, gets the actual web request, and makes sure there's nothing malicious in that request. And then it forwards it on to the backend system. So Capital One, trying to do the right thing, deploy a security device at their border, at their edge. They're trying to deploy this device to increase their security. But as it turns out, this device was misconfigured in a way that caused them to lose everything. And so we'll talk specifically about what happened here. But basically, the site was configured to do an SSRF attack, and then that pulled a critical access token off of the WAF, and then allowed them full access to all of Capital One's storage buckets on the back end. And then here is the king of all case studies. This is basically got all of the above, right? This is Instagram's bug from sequence of bugs from 2015. They had issues where they had a web vulnerability, which was a Ruby deserialization remote code exec bug. So in CS, when you serialize an object, you want to make sure that you're only ever serializing things that are data and not code. Well, if you're passing around serialized Ruby objects over the network, well then, if someone passes you a malicious one that's got some malicious code to execute on it, then you get this deserialization vulnerability. And it was done via a cookie. And so that's the initial compromise. That was the initial vulnerability. But then the adversary was able to pivot from that to find hard-coded tokens in code, to find weak passwords being used on the Instagram backend. So passwords like change me password, the common ones that you see in the top 100 passwords being used. They found database credentials stored in a file. They saw AWS access keys stored in a file. They saw unprotected application backups, and these things also contain key material. And it was this particular thing that they saw key material for like a master account on the Instagram backend. And so this key was over provisioned, and then this key allowed them access to the source code of the site, the assets, the SSL certificates, which is really bad. If you're a website and you coughed up your certificates and your private keys, that's really bad. API and OAuth keys. So all of this, and these are folks who they're probably way better at security than I am. So it's like, well, this is the problem we're facing when it comes to securing the cloud. Okay, so it is not a surprise that criminals are taking advantage, right? Anytime there is this kind of, I guess, chaos, then you will see opportunities for people, miscreants, to get in there and then cause trouble. And so you can see 44% of all these criminals are using the cloud and abusing it. One of the more famous ones is people have found that a lot of the adversaries are getting onto Azure and using Office 365 as a delivery mechanism for malware and for compromising other accounts. So these cyber criminals are definitely becoming cloud enabled. But the question is, are Oregon students the same? Are we preparing this current generation of students to also tackle the cloud and the security issues in the cloud? And if you look, these are numbers that you'll see a lot in Oregon higher education. These are numbers that justify at least June and my existence. The numbers aren't very good in security. We're falling behind, and we need to do something about it. And so hopefully this was the reason for that camp that June mentioned on Saturday. We need to engage the next generation of students to basically pursue this discipline. And hopefully we can engage them in a way that's actually fun, that actually keeps them in the discipline and doesn't cause them to run away screaming because this is bloody hell. It's way too complicated. It's too frustrating. It's hard, this, that, and the other. So we're trying to improve these numbers by really engaging students. And my preferred way of engaging students is with games. I like playing them, and I think a lot of other students like playing them as well. And so you'll see that games are they're at the heart of almost everything we teach here in Portland State. A lot. So with Charles Wright, we basically about 7 or 8 years ago, we just started putting CTF games throughout all of our courses. And so one of the courses that we run is Web and Cloud Security. And basically all of these exercises, they're either code labs, which are just walkthroughs of things to do, or they're like CTF levels that they go and they solve. And so we folded the CTF and the game approach into this to try and teach students how to learn issues in cybersecurity in a really interesting and engaging way. And so we got to the cloud security part. And we're like, great, there's all sorts of exercises on AWS. We have the serverless GOAT, that's AWS, that PureSec developed it and then open sourced it. And then it's now part of OAuth, the serverless GOAT. So we could use that, that's cool. There was Rhino Security Labs has their cloud GOAT. Again, they open sourced it, they made it free for anyone to use, again, but that's AWS because AWS is pretty much running 80%. Well, Azure is running a significant amount now, but at the time, AWS was basically the one and only place to run stuff. And then there's also Flaws and Flaws 2, and these are really excellent exercises. But again, so Summit Route hosts these. So these are things, this is even better because the projects that run them, you don't have to run anything. Like the first two, you basically have to run your own version of them in order to get it to work. But the Flaws and the Flaws 2, you could just run those. Well, you do need an AWS account. So if you're part of AWS Educate, you actually have to have an account to do these things. But they're free, like they're hosted, right? So you can just point students to it, and then they can play these games and have a really good time. But we do a lot of Google Cloud here at Portland State. And so we're looking around and we're like, well, how do I teach people about Google Cloud Security? And so it turns out there's nothing. So we decided to build one ourselves. So that's what Thunder CTF is. It's a cloud security CTF for Google Cloud Platform. We wanted to, so you'll see this a lot in some of the CTFs that we've developed here at Portland State. We really pay attention to the design because we want students to get confidence and competence out of the exercise. So we don't want to waste their time. We don't want them to sit there frustrated in doing their learning. We want them to have a really good progression of learning. And so you'll see that the design of the CTF is based on scenarios. And this allows students to role play an actual exploit, to really get their feet in the shoes of a potential adversary and see the process that it would take to go from one potentially compromised account all the way through to a full jailbreak. So we think that that's engaging. Students kind of like that, to see an end-to-end thing. It's scaffolded to support differentiated instruction. And this is really important because we don't know what level a student is going to approach this CTF with. It could be that the student is an expert, has been navigating Google Cloud in their internships since whenever. They could be really good at it. But they could also be completely new to Google Cloud. And so we wanted to make sure that it was scaffolded in a way that supported both, that supported differentiated instruction. And we'll talk about what parts of this design support that. It has to be extensible. So if you're in security long enough, you realize that the course you offer today probably isn't going to be the course you offer next year, because everything is changing, right? Like the threats are changing enough that like I joke, they never offer the same course twice. So you're always having to update it. And similarly with the CTF, you have to update that thing so that you're not training students on bug classes that are dead. Like you have to actually get them out of that, because that's not useful useful for them to learn again if they'll never come across it again. So you need the CTF that you send them through to be extensible. You need to be able to easily add and remove levels. And if there's time at the end of this, I'll take you through a little bit of a walkthrough of how you would add a level in our CTF. And then finally, it should be frictionless to set up. It should be easy for a student to get up and running. It should have low cost. It should not cost a lot of money to run all this stuff. It should be polymorphic. So if you're a teacher and you want to deploy this in a classroom, you got to make sure the student has done the work of the CTF. And so we make the levels a little bit polymorphic so that they have to demonstrate unique work has been done through this exercise. Okay, so I am going to talk about each one of these and how Thunder CTF embodies each of these particular design goals. I'm going to first start with the scenario-based part of this. And to do this, to motivate this, I'm going to talk about the Mitre Att&ck framework. This is a framework, it's a taxonomy of adversarial behavior. And it's a way of classifying all of the different things that adversaries will do when they're trying to basically break into your project and then move around and then to do whatever or to obtain whatever goal they need to obtain off of your back end. So this is an industry, it's basically an industry standard enumeration now. I think everyone has adopted it as a way to talk about attacks. And you'll often see when they describe APT crews and what they're doing, they'll throw up a Mitre Att&ck taxonomy and say, oh, these are the different tactics, and then the different techniques in each tactic, and then their procedures of using them to affect their goal. And so that's what the Mitre Att&ck framework does. And then this is a figure, so I like talking about it is probably not as effective as showing you just a picture of an example of the Mitre Att&ck framework. And so here it is as a matrix, and it's often presented as a matrix. And what you have across the top are the different categories of tactics that an adversary will use. So initial access is always the first step. How do they get onto your platform or your project or your enterprise? How do they get code execution? How do they persist in your environment? How do they escalate their privileges to get more access to your backend? How do they evade the defenses that you have put in place to detect them? How do they access credentials that they're not supposed to access? How do they discover things that are running in your backend? How do they move around from their initial starting point? How do they get to other places in your project and platform? platform? How do they collect information about your enterprise, your networks, your accounts? How do they talk back to the mothership? How do they communicate to their backends to allow them to control the compromise? How do they exfiltrate data? And then finally, impact. What are their goals? And exfiltration might have been their goal, but there's a number of other things that they could do. And then, so those are the major tactics. And then in each column, what you have are the different techniques that are related to that tactic. So initial access, maybe it's a vulnerability in the front end application. Maybe it's a spear phishing attachment. That's how they actually get, getting someone, a victim, to click on that might be their initial access. And likewise, going down in each column, you'll see an enumeration of all the techniques that are associated with that particular tactic. The last thing is the procedure. And so every APT crew, every adversary has what they call a playbook. In fact, you can, like, the hacker's playbook is one of the more famous books that's out there. Everybody's got a playbook. Even defenders have their own playbook for doing incident response because they have their own tooling that they're good at and that they know how to use. Likewise, adversaries have a playbook based on what are their current capabilities. So it could be, I'm really good at spear phishing, or I really have mastered lateral movement and I can use these homegrown tools to do that. So every adversary has a playbook, and that's basically what a procedure is. And you see everything in green. Maybe the attacker is really good at everything in green. And then in order to actually get all the way to the right-hand side, they'll chain a bunch of these things together. And so the really powerful thing about Mitre Att&ck is that, hey, if you can find a weak link, say if a particular APT crew relies on one technique to perform defensive evasion, if you can make sure that that technique doesn't work anymore, you have stopped the APT crew. So there's an interactive site, and one of the things I like to do in my classes is show the APT crew the Fancy Bear. So you can see Fancy Bear's procedures, and then you can look at sort of what tactics you would target Fancy Bear with in order to prevent them from tampering with our election. And so that's something that brings it home, actually, because then you're like, oh, well, this is an organic thing, and then you can sort of see how this framework is enabling you to zero in on really the most effective means to stop a particular threat actor. Okay, so that's enough about scenario. The Mitre Att&ck. So Mitre Att&ck has developed a framework for Google Cloud and for cloud platforms, because this taxonomy here, this is more for enterprise security. So these are things like on desktop machines where you're managing fleets of your employees' infrastructure. But like there's a separate framework for Google Cloud, and you see it's got similar tactics and it's got similar techniques. And so we really wanted to build our CTF to demonstrate the TTPs that are in Mitre Att&ck for GCP. And so you will see our scenarios that we have built for Thunder CTF. They follow the procedures that are used throughout an entire attack lifetime of an adversary compromising a cloud project. And it's not just focused on app exploitation. I know in a lot of, in fact, we had this, we were focusing mostly on the initial vulnerability, right? Like binary exploitation. We were like, well, we have a whole course doing binary exploitation, but as it turns out, that's only like one column. And so we wanted our scenarios to demonstrate the sort of the wide range of adversarial behavior that's out there. And so we were like, okay, we have this Mitre Att&ck framework for GCP. We want to look at each one of these things. So over provision permissions, weak IAM policies, IAM privilege escalation, keys and code, access token compromise, backdoors via metadata. So metadata is something that we have to explain in our cloud security class. What is it? How do you use it? This is basically like the family jewels of credential information is stored in the metadata, or project jewels, I should say. The project jewels are like stored in metadata sometimes. And so these are things that we want to put into our CTF. And you'll see in the scenario I'm going to go through, it's got a little bit of each one of these. Okay, so here's an example. This is, we have 6 levels in Thunder CTF right now, and this is the last level. This is the capstone level of the CTF. So this is a scenario that is modeled after the Capital One breach. So if you see a breakdown of what the adversaries did in the Capital One breach, you can see echoes of that in this particular scenario. And we wanted to, in fact, we refer to the Capital One breach just to ground students in knowing that what they're doing isn't some academic theoretical thing. This is actually the techniques that were being used just recently. So one of the things that they do is they, compromised account key. So maybe it was uploaded to Git. They can, from that key, they can start listing the cloud project's compute engine instances. They can view the virtual machine's metadata to see maybe, oh, it's running a container. So maybe it's a container-based deployment, and then the virtual machine is set up to instantly run a particular container when it's brought up. And then they see that the container image is exposed in the project, and they can pull a copy of the container image and view how that container was built. And if they look at the container, they can see, oh, there's some sort of proxy functionality in this container. And then web proxies are a definite target for SSRF attacks. So this is server-side request forgery. Can I get that proxy to act on my behalf to retrieve something that I wouldn't have been able to retrieve directly? That's basically what an SSRF attack is. And moreover, if I can point that SSRF attack to the metadata server to get the credentials of a virtual machine, then I can actually get those access credentials myself. And that's what this level does. You get the credentials from the metadata service, and then you can if the credentials are over provisioned, then maybe those credentials will get you access to storage buckets that you shouldn't have access to, which is basically what happened in Capital One. And then you can exfiltrate all of the data in that particular storage bucket. So this is basically a walkthrough, a visual walkthrough of what you would do in this level. You might do a Docker history. You'll see that this is basically the container image. The container layers, the container image layers that are being that go into building this particular container. You can go and you can look at one of the layers you'll see is copying the source code into the container image. And then you can see from there, if you can get a copy of that source code, you can see that in the application, there is some kind of proxy functionality. And then if you bring up the proxy functionality, then maybe you can try and access the metadata service through that proxy. And then by doing so, you'll see you'll end up getting an access token. And then when you actually use that access token, you can then go into a storage bucket and pull credentials out. So this is just an example. This is a little simplified. You got to do a lot more than this to solve that level, but not a lot more, but like there's other parts of this. But this is just to give you an idea of what we're shooting for in the CTF. The next thing about this CTF is that it's scaffolded. And one of the things that we've noticed is that CTFs can be very evaluative and very competitive. And we explicitly don't want to put that in our curriculum. We want everybody to finish the CTFs that we give them. We don't want to rank people. We don't want to have winners and losers. We just want people to have fun. And so you will see that a lot of CTFs have these really esoteric levels that they're only expecting 1 or 2 people to solve. The worst case scenario for us is that a student spends like 3 or 4 hours on a level and doesn't solve it. So we're trying to avoid that. And to do so, in the design of our CTF, we are specifically looking to do differentiated instruction. And so it's often the case that students will play this multiple times And then each time they replay it, they get more out of it, because then they get a little, it's replay, like it's got some replay. I think it has some replay capacity. And the way we do this is through a really well thought out hint system. And so the hint system allows you to get a step-by-step walkthrough of actually solving the level. And so what happens is, if you just want to robotically enter in all the commands to solve a level, you can do that by just clicking on the next hint, the next hint, the next hint, and the next hint. We call that direct instruction. That's basically what our code labs are, our direct instruction sort of approaches. But if you do that once, then the next time you come back, maybe you'll see if you can actually generate the steps on your own without having to look at the hint system. Or if you're an expert at Google Cloud, like if you're born an expert in Google Cloud, you can just ignore the hints. See if you can solve that thing without any of them. And so that's basically the design of our hint system, to allow you can choose how much support you need, and it's given on demand, right? Like you are in control of how much help that you get. And so really, we feel that this balances challenge and struggle to target this psychological state called flow. And so if you've played CTFs and there's enough challenge, but there's not too much struggle, and you can make incremental progress, every 5 minutes you get a carrot, then you're going to be engaged. And that's why we really want people to stay engaged. So that's why we have this hint system there, because in the end, we want them to feel good about doing this exercise. Okay, so that's the notion with the scaffolding. And so you can see in the hint system, so this is A6 container. We can just give you some hints, say, hey, you know what, this thing, if you look at the metadata, it's got this as a Docker image. Maybe you can look into that and find out what the next step should be. Or like, this is a hint 11. Maybe here's a link to the metadata service that is on Google. So a lot of them will need that hint, actually, unless I teach them specifically about. I do teach them specifically about the metadata service, but like they need to know that in order to try and look for it to be on a system. Okay, the next thing is that it's extensible. So because of the shifting threat models that are out there and the countermeasures being applied, you got to keep shifting your levels. And so one of the things is that metadata exploit I've been talking about, that got capital 1, that's actually soon to be a dead bug class. So you need to be able to pull that thing out. And so, yeah, you do require a continuous change in the content. So it has to be easy to go in there and modify the CTF. And that's what our framework supports. It supports not only, deleting is really easy, but also the development of new levels. So we have pretty good framework for navigating at least the Google Cloud portions of it. We have explicit support for namespaces so that you can develop your own CTF sequence in it without having to re-engineer a whole bunch of code. Like there's a community subsection that allows people to build off of the same code base. And so you can see here, this is the a condensed version of the UI, so the namespace. So there's we have 2 CTFs, one we're working on, but then Thunder is the first one. So these are the different levels, and you see the namespace for each of them. And this is just a quick look at the framework that we provide for developing levels. You'll see that the levels are using a lot of infrastructure as code to consistently deploy the level onto a user's project. So our model is we don't host the actual cloud infrastructure that the students are attacking. They basically will clone this repository and then deploy their own levels. And these levels will be polymorphically generated so that we'll know that they've done it themselves. And so we use on Google Cloud Platform, their infrastructure as code solution is Cloud Deployment Manager. So we use basically YAML specific. So it takes YAML. So YAML is yet another markup language. So YAML is similar to HTML. It's a way that most cloud resources are being specified in YAML files. And you'll see this for a lot of infrastructure as code deployments. They're going to use declarative approaches for specifying the infrastructure they want to deploy. So it's a combination of YAML files to manage the deployment, and then a little bit of Python code to programmatically add some of the features of the level into the infrastructure. And so this is what we have in terms of a framework. We have different helper functions in Python. We have a Python development script that will write into it, and then we'll have a YAML specification. So on the left, the level designer supplies the YAML for the infrastructure specification, has a Python development script for programmatically adding certain things into the level. And then the last thing that a level designer needs to supply is a hint content file. And this will be ingested straight into the hint system in order to provide the interactive step-by-step walkthrough of a level. And then we provide in the CTF framework a bunch of helper functions, a better interface to deployment manager. Nick found that he was doing a whole bunch of things repetitively in some of his levels. So we have a better way of accessing that. Well, we think. Well, we have our way. We have a better way for us, I should say. I don't want to say it's downright better for everyone. And then we have some automation to generate the deployed infrastructure. So when the student runs the script, everything gets deployed properly. And then the website with the hints on it are also produced. Okay. So there's a development guide here, and then there's a CTF framework documentation that you can get access to if you're interested in extending it or creating your own. That's what these things are for, if you're interested later. The last thing, it's deployable. It only requires a Google Cloud Platform account to play. It consumes a minimal amount of resources. In fact, we try to make everything in this CTF as serverless as possible, because the only real money that you're spending is if you use hosted services on Google, or if you're spinning up actual hardware that becomes idle if you're not using it. So we try and make it to use as much serverless infrastructure as possible. And most of the resource usage for the infrastructure we spin up is within the free tier offerings of Google Cloud Platform. For example, for levels that do require us to actually deploy a server, like a virtual machine, we're using an F1 Micro, which is like free to use, as long as you only instantiate one of them per project. So it's like we can deal with that. Like we don't need a lot of compute for our CTF. So yeah, we can fit that in the free tier. And so you can play the entire CTF for under a dime, which is sort of why, learning cloud security for on a dime. That's where that comes from, because you can basically get students, like when we run this in courses, they get a $50 coupon, and this thing will cost them 10 cents to run. So then they can use their coupon for whatever else they, crypto mine or whatever else they want to use the credit for. Actually, they probably shouldn't use the credit to do crypto mining. That'll get us in trouble, actually. Okay, so if you want to run this in your courses, code is freely available. It's got a really simple interface, Python, Thunder, create, and then that level. You can only create and deploy one level at a time. And then you can create it and you can destroy it. And then I mentioned earlier, it's polymorphic in the way it generates the levels. I can do a code walkthrough to show you what's going on in terms of that at the very end. I'm going to do a demo first, and then if there's time, I can walk through some of the code itself. And so we've run this a couple times. We ran it in fall of last year. We ran it again in winter after we got a lot of the kinks worked out. And so we did a survey. We tried to evaluate this. And the rating, 1 was very unhelpful, 5 was very helpful. We had 36 out of 48. This is data from the fall of 2019 offering. And so students really liked the exercise for helping understand security issues, and then for developing skills and navigating the cloud. And they really liked the hint system for being able to get make progress quickly. So I think this is the big number that we were looking for, because I think this is pretty good design. If you're going to build a CTF into the classroom, this is really important, this hint system, to get people unstuck. Okay, so I can take some questions now before I do a demo. And if you have a Google Cloud account, you're more than welcome to play along. So you can bring up a window, get set up. But this is going to have a spoiler. So if you actually want to play this on your own and not have it be spoiled for you, you could probably just maybe, walk away for a while, or take off and then watch the rest of this recording later. Otherwise, that's what I'm going to do. I'm just going to give you an idea of how you would play one of the levels. So if you have any questions, you can put it in the chat if you don't want to show up in the recorded video, and then I'll just go from there. So
I don't have a question, but I have a comment. I really appreciate your integration of research into education. And many of our researchers, we like to do good research, but many of our research often has a difficulty to be integrated into education. And I see you have done a lot of thinking to try to integrate your cloud security research into the education. This is really wonderful. I particularly like the hint system myself. I think that's a pretty cool design. I like that myself, even without using it myself. It's
and
pretty cool.
The researcher moniker I didn't really identify it with it as much as I get later on in my career. I'm definitely a game player. So if you look at this, is just for me, this was the why I got into computer science, was to play games. And so the research thing was a means to play games. So yeah, there's a little bit of research here, but yeah, definitely I'm really interested in gameplay. So this is where we would welcome contributions from real researchers in the field to put, maybe some kind of exercise in there that actually is more bleeding edge. Yeah. So with that, there were no questions in the chat. I'm gonna play a demo. Let me see. I'm gonna play A2 Finance. So in my browser, this is a Cloud Shell. So in Google Cloud Platform, they supply this Cloud Shell feature, which is a really good way of managing all the resources on your project. It's like a container that is hosted by Google and then contains all their software tools in it. And so for students, this is a total boon. It's like having a Linux command line without actually having to run or install or SSH into anything. You basically click this, I'll close it. So you basically log into your project. And so you'll see this is my Google account that I've logged in, and then you click on this Cloud Shell, and it basically launches you a container that's got a full Linux distribution, and it's got all of the Google Cloud packages in it. And so all of the levels in Thunder CTF are playable within the shell, within Cloud Shell, and that also makes it easy because now the student doesn't have to install a bunch of stuff to get up and running on the CTF. They can just go to all playable in a web browser. And that was really important to us in terms of design. So one of the things I want to show you, there are explicit instructions that you have to follow to get set up. And so these are, you just have to set your project. This command sets what cloud platform project you're using. And as it turns out, this is actually automatically set in Cloud Shell. This is the project that I'm using, TCTF 01. And then you basically create a Python virtual environment. You clone the source code, you change into the repo, and then you install the Python packages that we depend upon. And one of the things that you would install is the Google, the packages for Cloud Deployment Manager, because we rely on Deployment Manager to deploy the infrastructure. And then there's this single command to do the setup, and it's called activate project. So when you start this on a fresh Google Cloud Platform project, one of the things that we rely upon is a bunch of the services to be enabled. And so we're actually, that's what this Activate project does. It just enables all of the services that we need, including all of the auditing logs for all of the platform services, because eventually you would want to poke into there and see what is actually being captured when I go and exploit this particular project. And so this is all the setup, and there's nothing too fancy about this. And then there's a help system here. So what we're going to do is, after we do this setup, we're going to go over here. We're going to play the Thunder A2 Finance level. And so there is, so after you activate the environment, we do have you configure your Git setup, and there's a reason for this. This is only for this particular level. You have to configure Git. And then to deploy a level, all you're doing is saying, Python Thunder create Thunder A2 Finance. One of the things after you do this deployment, and I've already pre-deployed this level, so we don't have to wait. After you do that, then there is a start directory that has all the level information. And all of the levels start with two things: a text description of what you need to do, like what is the goal? What is so the adversary has their procedures. What is the last one, the impact that the adversary wants to have? And that completes the CTF, the CTF level. And then the other thing is an initial access credential. So typically when you get onto, when you compromise a project, you'll get some kind of credential. And so at the beginning of each level, you're typically activating a credential. And that's what this command is doing. So that gets you started. And so I'll go over here to the directory. And I'll go into, I have it here in tctf. So I'll activate the account. And then I've already, so I mentioned I already launched this thing. So in the start directory, you'll see these two files. And so a2finance.txt. You can see, use the compromised service account credentials stored in a2access.json to find the credit card number for Mary Owens, which is hidden somewhere in the GCP project. So that is my mission, Mary Owens. So I have to remember her name so that when I come across this, I know I've solved the level. And then the goal of the CTF level is to do it, for us, it's to take a screenshot of Mary's credit card number as it pops up in the cloud project. So that's our goal. And so I'm going to start with I'm going to activate this service account. And so this is, oh, actually, I need to hang on a second. I need to get into this directory. So I run this command, and this is where you're going to take on the credentials of this particular service account. Now, really, because you own the project and you deployed all the infrastructure, you have owner access to this project. So realistically, you could get access to everything, right? And so this is sort of like the honor system, is like, run this command. And if you don't know any better, like a student might not know that they're basically God on their own project. So this is a simulation. We want you to reduce the privileges back to what an adversary would get. And the adversary might get an account that has a minimal set of privileges. And so that's what we start students with on every level. And then, so that's the command. And so when you get access to a credential, one of the important things for an adversary to do is say, what does this thing have access to? Like, what are the permissions associated with this credential? And so we have a script. So basically, you can brute force the permissions on Google Cloud and then see if that credential has that particular permission. And so we wrote a program that does this. It's called test permissions. And then we just, it's supplied. You can actually use the test permission script on any credential that you get in Google Cloud. And so this is just a script in our scripts directory. And then this is actually encoded in the hint system. So if I do test permissions, and then I give it the path name for the JSON file, it's going to go through there and it's going to check every single permission on Google Cloud Platform. There's like 1,000 of them. maybe not 1,000. There's like 800 different permissions. Actually, it might be 1,000 now. There were 800 when this thing got written, but they keep adding permissions. And then they wonder why people are getting confused. But like out of the 800 permissions, this particular credential only has this set. It's got 5 permissions, listing buckets, listing zones, getting the zones, listing instances, compute engine instances, and then getting them. So really restricted set. But as soon as you see that you have access to storage buckets, one of the things you would do is like, well, can I list all the storage buckets and maybe can I get stuff from them? And that's basically what this gsutil command does. So if I do a gsutil, and it takes a Unix, basically a Unix interface for the subcommands. So I'll just do a gsutil ls and see what kind of, oh, I have to authorize it. What kind of credentials do I have? And it says, oh, I have, a couple buckets here. This is for App Engine. Those aren't the ones that we really care about. Here's one that looks like it's for this level. And I'm like, okay, let me see what's in that bucket. So I'll do a gsutil ls gs : / a2 bucket 35. Oh, I'll cut and paste. Let me see what's in that bucket. And so you see, hey, there's a Git repository and a function. So, all right, well, let me exfiltrate that data out of that bucket and then poke around. So I'm going to make a directory here, and then I'm going to see if I can just copy all of the contents of that bucket. And then this copies all of that data over. So I have a2 bucket. And if you go into this function, you see, and this is intentional. There's nothing in main.py and there's nothing in requirements.txt. Don't look there. But it's got a Git repository. And so one of the things that we talked about earlier was that people are leaving things in their Git repository. And even if you commit and push, and you immediately commit and push a version that doesn't have the key in there to try and fix your mistake, your key is still sitting there in that Git repository. And so you can do a Git status in this directory, say you're on branch master, nothing to commit, nothing in this directory. But you could look into the Git history, and then you can say, oh, added the initial files in this commit. And then you see the next commit was, oops, deleted the accidental key upload. And then you can say, well, let me, so Git allows you to turn back time. So let me do a Git checkout of B4CC9C. And then if you go back and you take a look at what's there, you can see, oh, look, there's an SSH key in here. So you can cat the SSH key. And you see, oh, well, maybe that's a credential that I can use to do some lateral movement in the cloud, to do some pivoting. And this is exactly the kind of exercise that an adversary would do on your cloud project, to try and be to move around, to get different kinds of access in the cloud. So what are we going to do with this credential? If you saw back in the test permissions command, I was able to see that I could actually list compute instances. So maybe this SSH key will allow me access to one of those compute instances. So that's what I'm going to do next. I'm going to do a gcloud compute instances list. One of the nice things about the gcloud command line is it does tab completions on the subparts of the command. And so if you do this list, you can see, hey, there's a logging instance sitting here in the compute engine service. So I have a virtual machine. So this is an F1 micro. It's in US West 1B. And it's got this external IP address and it's running. So maybe I can see its metadata. And the way to get the metadata on this, because if you recall in the permissions that I got, I have compute instances get as well as compute instances list. So now I can list the compute engine instance and I can get the description of it. So that's what I'm going to do next. Instance describe, and then I'm going to use the name of the thing I want to. Does tab completion work? Yes, tab completion does work. So then I'm going to describe this instance, and then you'll see a whole bunch of stuff go by. One of the things you'll see is let's see here, let's scroll up. You'll see the external IP address of the instance. You'll see the commands that were executed when I started the virtual machine up. But here's the thing that we want you to see. You see this. This is basically in your metadata. You basically have the different SSH public keys that are allowed access to this VM by just using SSH. And so you see, here's an SSH key for cloud user. And maybe the private key that I exfiltrated is the private key for this public key here. So that's interesting. So that's what I'll try. So then maybe here, well, one of the things you have to do, SSH doesn't like it if its permissions are wide open on their key. So the one thing that you have to do is change these permissions. And I think this is given in the level, like in the hint walkthroughs, we talk about this. And so now I can use this SSH key to go to cloud user at this IP address up here. And see, does that get me access? And of course, I'm able to log into this virtual machine. One of the things that I don't know if it's in this particular level, but one of the things you can do as soon as you're on a virtual machine on the cloud project, you can poke around and get its tokens. So there are two kinds of tokens in Google Cloud. There's the identity token that says who you are. And then there's the access token that says, what are your privileges? What can you get at? So gcloud auth print identity token is the identity one. So you can get your the identity of the machine itself, and you can get its token. The one that we're interested in is print the access token. And so this is the token. Whenever this particular virtual machine accesses anything else on the cloud project, it's going to supply this token, this access token, to validate that is authorized. So that's extremely valuable because now we can pretend to be this logging instance. I mentioned earlier this whole metadata service exploit. The whole metadata service exploit is to try and get this access token out of the instance that's running your piece of software. And so one of the things that you'll see is that this access token is, so the canonical SSRF that gets you tokens in the cloud, at least for Google Cloud, is what I've just pasted there. So this is going to the internal metadata service and saying, what is the service, what is the token associated with the service account running this compute engine instance? And then you can see this access token is exactly the same as the access token that it's hard to see, but like it's the same as the one that I used for that. And that's the SSRF attack. And so this, when it comes to A6 container, we really explain this, but I'm just showing you this here because you can get at if I had a proxy on this machine that allowed me to retrieve this, then I'm able to pull the access token out of this virtual machine. Okay, one of the things I can do with this access token is I can use my test permission script to say, well, what does this token have access to? So that's what I'm going to do next. I'm going to create another shell here because I'm SSH'd into that VM, and I need another. My test permission scripts is on this Cloud Shell thing. So I'm going to go into CTF, and I'm going to go into I gotta in activate. I'm going to go into Thunder CTF. There's the script, so I can do a Python scripts, test permissions, and I can just, this script either takes a file which contains a credential, or it just takes the credential straight up and then it tests it. So one of the things I can do is I can say, well, what are the permissions associated with this token? And you can see it has access to the logging backend. So yeah, it's pretty reasonably permissioned, so we think. But one of the things it does is well, it's basically got all the log entries. It's got access to all of them. One of the things we teach in our web security class is that the log entries can be a perfectly good way to exfiltrate data for an app. Like the adversary will often look at all the logs that they can collect, because it's often the case, unless you sanitize your log entries, that there's potentially very valuable information in error files. And so that's what, since we can list all of the log entries, we're going to use this credential to poke around the log files. And so let's go back to the SSH session. And so we're on the logging VM. And so I can use just the regular gcloud logging commands to list what logs are being kept. One of the things you'll find in the cloud is that because you have distributed infrastructure, you don't want distributed logging. You don't want to actually, when you have a question to ask on like what events have happened in my cloud project, you don't want to have to programmatically go to all the different components of your infrastructure to figure out what the logs are. And so typically you would have a centralized service ingesting logs that are being sent to it from all the different parts of platform services. And that's what this Stackdriver, well, it used to be Stackdriver logging, but this is what the logging infrastructure, the native logging infrastructure in Google Cloud is giving you. And so you can see these are all the different logs that this particular project has access to, or this particular virtual machine. Now, typically, when you set up something for logging, you want write only. Like there is no reason for this logging instance to be able to read the logs after, right? Like if you have a thing that's just reporting events, there's no reason for that thing to also need to read the events. And so this is the over-provisioned part. That access token looks like it has just logging, but what it really needed was just write-only logging. You didn't want to have it be able to read the logs as well. And so this is the vulnerability. Here's a log file that looks pretty juicy. It's got transactions. And so let me see if I can read that. So gcloud logging. Oh, I don't have command completion set up on this VM for this. Let me copy and paste this log entry. And then you can see what comes back. So this is actually this is querying the centralized logging infrastructure and then coming back and oh, it's not there. Something else happened. I may have deleted these logs. So here's the so I deployed the level too early. This level has been around. The logs actually there's a time limit on the logs. So the log got deleted because it got timed out. So I can't finish the demo, but basically you would see the list of credit card transactions and you would see Mary Owens showing up on that. Okay, darn. I should have just deployed it right before I started this presentation. This thing's been around for a couple of weeks, unfortunately. So, all right, that's too bad. Okay, so that is a demo of one of the levels. And so I want to recap what we just did to just really bring this back. Like, what are we doing here? And so you see the sequence of we're trying to show them like the different parts of Mitre Att&ck. And so what you saw was you first got a set of initial permissions. So that was where the activate service account came from. Then you did a bunch of service discovery. So given those permissions, you saw what services it had access to. And then you did a list of the storage buckets. Eventually, you ended up doing service discovery on the compute engine instances the second time around. And then you actually access the storage on the platform. And then, so that's part of collection. And then you exfiltrated that data by copying out. So this is part exfiltration, part getting the key out of the Git repository. Then you found a credential stored in the project. And so this was an SSH key stored in the file. And then you did another round of service discovery to find the compute engine instance. And then you found a valid account that had elevated privileges. And then that got you access to the logging. And then you should have found the unsanitized error log that you could then exfiltrate the credit card of Mary Owens. I wish that would have worked for you, because that's actually, that's like that's the whole point, is to get the carrot at the end. And yeah, it would have failed. So some future work, we're additional levels. We're actually trying to develop different kinds of CTFs using this framework. Additional play modes, and then we're just using this in courses as much as we can to see what works and what doesn't. One of the things that we noticed is that in the cloud, you run something once, and then the next time around, something has changed, and you pray that it hasn't broken your exercise. But you're always, this is like continuous integration, continuous deployment, CI/CD in the software world. That's basically what you're up against. And so every quarter I run this, the TA and I are trying to figure out what still works and what we need to fix. But one of the things about using this as a shared resource is that one person has to do this, and then and we're the ones who are keeping Thunder CTF up to date. So then, if you want to use it and you have an issue, we would be the ones to talk to about getting that fixed. Okay, so I'm going to take some questions now. There's some time here. Yeah, so CTF stands for capture the flag. Yep. And in this case, the flag is that integer or that credit card number that we want people to find. I could also do a little bit of a code walkthrough if people are interested in it, the Python script and the YAML for the level, if that's something that people want to see.
So has anyone outside of PDX used Thunder CTF?
We haven't even published it yet. So no, I would say no. No, not that I know of. But you're more than welcome to use it. It's just, yeah, we haven't really. So this actually, the Google Cloud Platform faculty experts have seen this. So some of them might have, but we don't track who's using it. I mean, that URL for running it and then the website, it's completely open. So yeah, we haven't actually seen, and no one has told us if they are using it. Yeah.
Might be nice to ask everyone who uses it to register, so you can list all of them on the website.
Yeah, yeah. Maybe if we had that foresight, I guess we should have. Yeah, yeah. Right now we don't. But yeah, that's a good idea. Maybe we should do that just to keep track of it. I'll just briefly go through a code walk. This will just take maybe 10 minutes if people have time. I can just show you an example of a level that. This is the A2 finance level, actually, and hopefully you can see this. I know, hopefully it's not too much of an eye chart. One of the things I want, just to get this, so if you've never seen cloud deployments like this before, done with infrastructure as code, here is a YAML file that basically, let me see if I can change the, let me, Well, hopefully that's still readable. So one of the things that happens in YAML files is that you're specifying a template, and then that template is going to get filled in at runtime, and then with any runtime parameters that you want. So the template is specifying the infrastructure you want to deploy, and then eventually that gets deployed using Deployment Manager. So one of the things, and the reason why I'm doing the A2 Access one is because now you're familiar with all the things that this thing has to deploy when it launches. And so you see, this is the vulnerable bucket that we had. And so we wanted to create this storage bucket, and we wanted it to be accessible by the A2 Access service account, because that's the initial credential that the users have. We also have this virtual machine. So this is the logging instance. And we want to set it up with the Google Cloud SDK, as well as we have to update it. We also want to set it up with that SSH key. So we have to declaratively specify that an SSH key is going to be attached to this virtual machine, but we haven't generated it yet. And so what's going to happen is that the Python script for deploying it is going to generate the SSH key and then pass this into the template so that it can actually at runtime instantiate the username and the public key. We have IAM policies because we need to configure what this particular service account up here has access to. So, and this should be familiar because that's what we had, when we got that credential, we were able to list that these were the permissions. So that's what the A2 Access account has the permissions for. We also have a service account for the virtual machine, and it's a separate service account, and it's a separate set of permissions because obviously we're trying to elevate our permissions. And so this thing has the predefined logging viewer role, as well as the logging writer. So we attach two roles to this particular account. And really, if you want to practice the principle of least privileges, you only wanted the log writer. And so here is where this is the mistake of adding the viewer role to this service account. So that's the over provisioning step. So that's basically it. Those are all the that's all the resources that we're deploying. And then the Python script will generate a bunch of these assets like the SSH keys. It'll generate the Git repository and then copy it into this bucket. And that's what's shown here. This is the Python script for deploying A2 Finance. You specify the path, the prefix, the log file entry, and then the create. When you say Python Thunder create this particular level, this is the polymorphism. This is your random number, so that it makes sure that everyone is got a different level, like the output of the level is different, so that we can make sure that they've done their own work. We specify the SSH username, and then we get a key, an SSH key for it. And then we create the repository locally. And what we want to do, this function will not only create the Git repository, it'll insert the SSH key into it, and then do all the commits necessary to construct that repository. And you can see in the create repo, you can see this is just a bunch of OS commands to basically create the directory structure, and then to write out the private key that we generated previously. And then if we go back up to the top, we see that there's some template files that we are going to use, and then we do the insert. So this is the Cloud Deployment Manager insertion, where you're deploying all the infrastructure. And then after all the infrastructure is deployed, we actually upload the Git repo to that bucket. And then we also, so we do that. And then we also have to create the credit card logs. So the transaction logs, and that's what create logs does. So this is all setting up all the different infrastructure of our project. And then the last thing we're doing is setting up our IAM accounts and our privileges. So it's just to give you an idea, and this is the entire level. And if you would need to create your own, this is what you're faced with. And we have a development guide to allow you to hopefully get up and running pretty quickly. And so there's a question about, are the log the logs over provisioned by default. And this is something they can be. So one of the things that Google Cloud provides you are these predefined roles that are commonly used collections of permissions that most people need. And they give it these they give it these names, like in this case, they give it the names logging viewer, logging log writer, and these are pre-canned roles that Google Cloud provides you, but you can create your own custom ones. And so the reason why they pre-canned a bunch of these is because people were getting tired of listing all the different permissions over and over again. And so they did the most common ones, which is the ones that are documented, but the most common ones aren't necessarily the ones with the least privileges, with the privileges that match your particular use. And if you really want to do the right job, you would specify a custom role that has just the permissions that you want attached to it. And that's what this one is. Like the A2 Access service account has just these permissions specified. So this is basically a custom role, whereas this particular service account has just used a predefined role that Google has given you. And so again, this is actually complicated. And this is one of the reasons why we got to be teaching this in classes, because if this really is the difference between Capital One getting breached or not, or my future credit card numbers in the cloud getting breached or not, we got to be teaching this stuff now. And because this level of complexity, I don't know when else you would learn it except right up front. Like we have to be like when people are introduced to the cloud, this is what they need to be learning, unfortunately, unless there's a different way of doing things, and hopefully there will be eventually a different and simpler way of doing things. Okay, and with that, I guess I'll stop there. Are there any other questions? You're muted, June.
Oh, sorry.
Okay.
I think we are running out of time pretty soon. I think this is quite interesting. This is quite eye-opening to myself. In fact, haven't seen you for a while, knowing what you are doing.
Playing games.
Yeah,
that's all I'm doing.
I think it's really good to have students to learn those hands-dirty skills at this level, so they could really have a direct experience, and they can readily use it as soon as they go to do such things. Yeah.
Yeah, and if they don't get the skills, at least they get the scare factor where they're like, oh, yeah, there's a lot of ways that this thing can go wrong. That's actually what I would want them to get out of any of these exercises, is that, yeah, these things are prone for errors.
This is wonderful. So I assume you will send us a recording link.
Yeah.
So some of the details could be further studied by our students and other people who cannot be here.
Yeah.
So
yeah, I'll find a way of uploading this to Google Cloud. I'll pull it off of Zoom. So it's recorded in Zoom, and I'll pull it off, and I'll give you a link.
Okay, wonderful.
Yeah.
Yeah. So
all right, thanks everyone for attending.
Yeah, let's thank Wu-chang, or maybe by, I don't know how we do that.
Do it over chat.
Thank you.
Yeah. This is the COVID era. It's like I'm only communicating with students over chat. And I'm like, okay, I don't have them turn on their video, so I don't get to see many of my students this year. So
hopefully this thing will be over, and we can have you come over at another time physically. So
yeah, maybe in person will be, maybe in a couple years. We'll see.
Hopefully.
Maybe in a year.
Yeah. Okay, Wu-chang, thank you so very much. Yeah.
All right. Thanks, June. I'll catch you all later.
Okay. Yeah. See you later. Bye.
Bye.